All right, friends and neighbors, welcome back to another networking video. Today we are doing chapter 10 in the CCNA, and we're going to do rapid spanning tree protocol and Etherchannel configuration. Now the difference here is that we've already talked about spanning tree a little bit. We know how it operates. We'll review that, but we're going to build a rapid spanning tree multi-VLAN topology, and we're also going to do an actual Etherchannel configuration, a layer 2 Etherchannel configuration. In this video, as always, we're going to do the do you know this already set of questions. We'll go kind of quick through those. They're a little complicated this time around. And the network exam topics that we're going through are obviously all the spanning tree stuff, but also the Etherchannel stuff, at least for the layer 2. They exist at layer 2 and layer 3. And then we'll do some examples for the BPDU guard and root guard features. And then we'll do a look ahead to IPv4 subnetting. Question 1 in the do you know this already? Which type value in the spanning tree mode type command uses or enables the use of RSTP? And the answer there is A, rapid PVST. We'll see that again today. Question number 2, examine the output of the show spanning tree VLAN 5 command. Which facts relate to the root bridge ID Ch10? Well, if you remember from last time, and we'll see later on, that what ends up happening is that the minute you have VLANs, we've got to have some way to indicate that there are VLANs. And one is that in this case, with this VLAN 5, that'll be the system extension, and the base priority will be 32.768. Question number 3, with Cisco Rapid PVST Plus, which of the following actions does a switch take to identify which VLAN is described by a BPDU? Choose 3. And this is related to all of the things that we were just talking about. The minute you're doing VLANs and the minute you're doing Rapid PVST Plus, what we're going to do is have some trunks. We're going to have a type length value in the BPDU that indicates the VLAN, and the VLAN ID will be in an extension field. So all of those are related to the fact that we're running per VLAN spanning tree plus, and that we've got trunks. Question number 4, a switch port is in access mode. An attacker replaces the host with a switch. So you unplug the host, put a switch in there, running spanning tree. Which features will result in changing the port to error disabled? Choose 2. And in this case, whether port fast was enabled or not, the minute you got BPDU guard there, and what ends up happening is you get a BPDU, the port will be shut down or disabled. Now, question number 5, the root guard has acted to disable a port after show commands, which answers list facts related or expected due to the root guard action. Choose 2. Well, this was A and E. The spanning tree port will be in broken, and the interface will still be connected, right? So this is we haven't unplugged or shut down the port, so it's still connected, but it'll be broken. Now we'll see that that's also an iOS version specific thing. So sometimes it'll just show that the port is in an unstable state or that it's listening. Question number 6, interfaces gigabit 01 and G0/2 are configured on the same ether channel. Which of the following terms is used in the configuration commands? We're going to do this. We'll see that it is the channel group. Question number 7, which combinations of keywords on the channel group interface subcommand on 2 neighboring switches, so you have 2 switches that are connected together, will cause the switches to use the link aggregation protocol to add the link to the ether channel? Well, what we'll find out is that in the link aggregation control protocol from the IEEE, one or both sides have to be active. Question number 8, a Cisco Catalyst switch needs to send frames over an ether channel, which describes how the switch balances traffic over the 4 active links. Okay, this has to do with load balancing, and so what we have to realize is that there's a mathematical calculation based on the fields that determines over which link the frame will be sent. So there we go. So what we're going to do today is try to understand more about how all this stuff works through yet another configuration, but this time with VLANs. So today, rapid spanning tree is usually the default, and this doesn't matter whether you're Cisco or somebody else, Juniper, what have you. Rapid spanning tree is usually the default. It's been around for a long time, but you should check. Make sure you don't have a mixed mode environment. They can interoperate, but the preference is for everybody to do it the same way. Now, in the diagram above me here, that is what we call a three-layer model. It might be a CLOS topology. And so in topologies like this, you have our access layer, and then our distribution layer, and then the core above us. The core is usually routing functions and things like that. It's all about speed. But at the distribution layer, right, we've got a lot of cross-connecting, a lot of redundant connections, and that is where we want our root switches to exist. Now that should make sense to you, but take a look at the complexity, right? That's why we sort of have to understand what in the world we're doing when we start to interconnect all of these devices. It's really, really important. Now, along the way, we saw last time that we have all kinds of fun terms with spanning tree, right? We've got designated ports and root switches and designated bridges. And then we change the mode of a port to an access port or a trunk port. But when we start looking at topologies like this, we also have distribution switches and access switches. And then the trunk lines could be also uplinks. Now you'll see terms like that when in this chapter, but especially when we get to chapter 17 on architecture. So that'll be a place where we really put all this stuff together. But for right now, we really want to understand the operation of spanning tree and rapid spanning tree. So here's a little bit of history and sort of underscores the need for multiple spanning trees. So back in the day when Radia Perlman was figuring out spanning tree, the standard that came out for bridging was 802.1d. And at that point, there weren't any switches, right? That's why the language is all about bridges. So if there were no switches, there were no VLANs either. And everything was in one big broadcast domain, which means that everybody saw everybody else's broadcast frames, multicast frames, or the flooded unknown destination MAC addresses. So now VLANs come around, right? Switches and VLANs come around, and Cisco comes up with per VLAN spanning tree plus, which is one tree per VLAN. So every single VLAN that you have has a different instance of spanning tree running. Now the IEEE was hot on their heels and developed 802.1w, which was later put in 802.1q. But while that introduced all kinds of speed improvements, it was still one broadcast domain. You still couldn't have VLANs that had different topologies. So Cisco has rapid PVST plus, lots of additional features. I mean, there was uplink fast and backbone fast, right? Port fast, all of those things, and multiple rapid spanning tree trees. What I want to make sure that you get here is that every single VLAN has its own instance of spanning tree. Well, what does that mean? That means that every single VLAN can have a different logical topology. So if you're forwarding traffic on one VLAN, it could go one direction, and in a different VLAN, the traffic could go in another direction at layer 2. It's kind of crazy. So the IEEE's answer to this was multiple spanning tree, and that's what lives inside 802.1q. All right. So when you're configuring a Cisco device and you're on the different modes, your different options, right? This is one of the parts to understanding Cisco command line options is that you can do PVST plus, rapid PVST plus, or the standard MSTP. So this is kind of a big deal, right? By default, and we'll see this, by default, all the VLANs will resolve to the exact same topology, meaning that you'll have the same root bridge for all VLANs. But that might be suboptimal. You might have resources for a particular VLAN that now have to go all the way around the topology to get them for the nodes in that VLAN. So what we often do is set up different routes for the different VLANs. So just a reminder, some of the things that we're going to talk about today, we're going to refresh our brains on some of these ideas. Now the big part today is the VLANs. And so the center box here, right, this whole center box shows us our default priority but the system extension as well, the VLAN ID. So you've got that, in this case, it's VLAN 101. And those two things combine to give us a different priority than the base priority. And then, of course, we've got our MAC address. And then we've got all the regular stuff here, but I just wanted to refresh your brains on the bridge protocol data unit that goes across the network. Well, what do we mean by trees? Remember that no matter how you hook up a network, right, you can have all of these connections and everything else. You might have loops and all that. Today, Ethernet topologies are either star wired or tree wired, meaning that there's no loops anywhere. Now, any switch can get to any other switch on a layer 2 topology, and we say that when we have a topology like that, it's a tree. So that's what spanning tree does, right? It blocks the loops and forces a tree-like topology on the virtual structure. Now, the minute we start saying VLANs, we have to do a couple things, right? We need our trunks, and across those trunks, we're going to use the VLAN ID to tag frames. And then we're also going to put in our BPDUs now that indication of the VLAN ID, and that's what we just saw in the BPDU. Now, when you do the output of show span, you can see these things. So right here, we can see that this switch has a priority of 4097. Well, it's a base priority in this case of 4096, right? That's the multiple, but it's 4097 because we're talking about VLAN 1. Same thing down here, a connected bridge, right, has a base priority of 32768 plus 1 for the VLAN. We can also see that the VLAN, the system ID extension, is 1 for VLAN 1. So this is what we have to sort of realize, that all of this information is right in front of us. We figure out how to look at it. Okay, so identifying the switch priority and the various bridges and the IDs for the system and so on. Now this is a blast from the past, right? This is what we did last time. So I'll just go through this real quick, right? The first thing that we do to identify the root switch is who's got the lowest bridge ID. That's the combination of the priority plus the MAC address. So no matter what VLAN we're talking about, you're going to put those together and you're going to take a look at the priority, and then you add the MAC address, and whoever has the lowest value becomes the root. And this is accomplished because we're going to exchange all the BPDUs with all this information in there. And the hint here, the little foreshadowing, is that if you have more than one VLAN, then you have more than one set of BPDUs that are going across the trunk lines and in between the switches. And then, of course, after that, as we're resolving our topology, as it converges, we're figuring out all the roles for all the switches and also the ports. So a root switch, designated ports, root ports, and so on. As we're going through all this, we know that the ports go through the various states, right? Listening, learning, forwarding, and then we've got blocked. Now, in the case of rapid spanning tree, one of the big differences is that on the blocked port, it's not really just blocked, it's blocked and alternate, or blocked and backup, which means that they're ready to step in very, very quickly if the topology changes. So this was all stuff that we did last time. This is just our review as we get used to how this topology today, the multi-VLAN topology, is going to resolve itself. And again, just a reminder, which ports to block, right? That's that comparison algorithm. Who's the root? What's the root path cost? What's the transmit bridge ID? What's the transmit port ID? So that's our comparison algorithm that we're going to use to get through there. And the path cost is based on the transmit port that you're using to get to the root. So gigabit was 4, fast Ethernet was 19, 100 or 10 megabit Ethernet was 100. And then anything from the root was going to have a path cost of 0. So that's how we figure out how to block. And we continue to block until there are no more loops. So you could have 50 loops out there, and you'll block enough ports till eventually you have a tree or a star. Now our bigger and broader stuff, right? We're going to do a rapid spanning tree topology with 1 tree per VLAN. So we're going to do that as a build. And the 2 features that we're going to fool around with today are the BPDU guard and the root guard. So remember that BPDU guard is all about I'm going to say I'm not supposed to get a BPDU on this port, right? So a lot of times we'll hook up a port to a node and we'll do port fast. And port fast says, warning, I'm not supposed to be connected to any other switches. So if you turn on BPDU guard, right, that'll protect that port and protect the topology. With root guard, this is a little different. You've got a root out there somewhere, and you want to make sure that that one stays the root. So if you put on root guard on a particular port, it'll prevent a new root, right, a better BPDU hello message from changing our topology. And this is where we get that broken or forced into nonstop listening port. Okay, let's do a couple of examples. Okay, so these are our two friends from last week. We are going to focus on this topology up here. And we can see from where the blocked port is that this is the root switch over here. So let's take a look at show span again and remind ourselves what this looks like. So I'm going to do a show spanning tree. Spanning tree. And we can see a couple things. We'll take it right from the top. Right here's VLAN 1. So this is about VLAN 1 then, this spanning tree instance. And we've got our default priority plus the system extension. So everybody is in VLAN 1. And this is our root. So let's do a couple of things. The first thing we're going to do is make all of these ports trunks. So port 23 and 24 all the way around, we're going to turn these into trunks because we're about to do VLANs. So if you remember how to do this, we're going to go to int f0/23 and we're going to say switch port mode trunk. Now we could do, we could put some to dynamic, but I'm just going to go around the horn here and put everybody into trunking mode. So the same thing up on the other switches. You can see that it says, I don't like the port type that you've got there. So we're going to fix that. Okay, so everybody should be trunks. So now all my links between the switches are now trunks. So we could say trunk here. This is a trunk, and I'll try not to put too many labels on things. All right, and we're doing trunks because we're going to do VLANs. Now this PC is connected to port 1. So what I'm going to do is I'm going to use the VLAN plus 100 as my numbering convention. So I'm going to say int f0/1 switch port access VLAN 101. Okay. And up here, this PC7 is in port 7. So I'm going to say int f0/7 switch port access VLAN 107. Okay, and then we'll do the same thing down here. We have PC2. So I am going to say int f0/2. I just happen to remember where I plugged these in, right? And switch port access VLAN 102. So now we have 3 VLANs in our topology. And while the ports are figuring this out, what's happening now, if we watch the BPDUs between the switches, now these BPDUs are going between the switches. Now that's a couple right in a row, right there. So those are the STP messages, the BPDUs going between, but these are actually for different VLANs. So let's see what ended up happening. Remember that this switch, switch 3, was the root, and therefore the spanning tree topology was based on switch 3 being sort of central, or the root of the tree. But now if we do a show spanning tree, we can see that we have VLAN 1 here, and this bridge is the root. But then we also have VLAN 101, and this bridge is the root. Well, what else do we have? we can see that we've got our trunking ports. Now this is something that I wanted to show you, right? These ports are part of a loop and they're designated in forwarding because they're on the route. But here, because they're going between switches, right, we defined an edge or an access point or an access port and a point-to-point ports. Point-to-point ports do not have any nodes on them. Well, what happens if we take a look at show spanning tree up here? Now remember, this is where I created VLAN 107. And we see that for VLAN 107, this bridge is the route. Now, why in the world would I want to have two different routes? Well, there's a couple of things. What if all of the resources for VLAN 107 were up here, and all the resources for VLAN 101 were down here? It doesn't make any sense for this to be the route and have to get to the topology via a different pathway. Notice that Packet Tracer is not showing that all the ports are blocked, or any ports are blocked. That's because for one VLAN or another, all the ports are forwarding, although if we look at switch 4, we can see that for VLAN 1, port 24 is forwarding, but port 23 is an alternate and blocked. And that's what we mean by the another role. So right now, its state is that it's blocked, but it's an alternate, meaning that if for some reason the topology changes, I could forward on this particular port. But if we take a look at VLAN 102, this bridge is the route for 102, and those same ports are forwarding. So again, we have three different routes, and the same port that might be blocking in one VLAN is now forwarding in another. Let's do one more thing before we leave this particular topology. I'm going to add another PC, and I'm going to connect this just to help my brain. I'm just going to connect it to port 7. Now what I'm going to do is I'm going to go in here, and I'm going to say int f0/7, and I'm going to say switch port access 107. Now, what do we think is going to happen? VLAN 107 will now exist on both of these switches. And what that means is that switch 3 was the route for VLAN 1. It was the route for VLAN 101. Will it supplant switch 2 as the route for VLAN 107? So here we've got VLAN 1. This bridge is the route. VLAN 101. This bridge is the route. VLAN 107. This bridge is the route. Okay, so this says a couple of things. One is that if I have VLANs everywhere on all the switches, then each VLAN's topology, each VLAN's tree will resolve itself in the exact same way as VLAN 1 did. So if I put all the VLANs on switch 3 would be the route for all the VLANs. If I don't have all the VLANs there, then wherever the VLANs live, that switch will be the route. But what if I still wanted switch 2 to be the route for VLAN 107? Right? Because right now, it's not. Right here we see that VLAN 107, here's the route ID, but it's not this bridge, right? This bridge is no longer the route. Well, here's how you fix that. We did this last week. We'll do it again here, but now we've got multiple VLANs. So now I'm going to say spanning tree. Now, these are the global parameters. So what I'm going to do is specify a change for this VLAN. So I'm going to say VLAN priority, VLAN 107 priority. Well, what do we want it to be? Well, it's going to be a multiple of 40196. We'll just do that, and then it'll add 107 to that. And what this does is it automatically gives makes this priority lower than the switch 3 priority for VLAN 107. And now we can see that for VLAN 107, this bridge is the root. There we have it. Okay, let's take a look at a couple of other experiments. All right, here we have a small 3-switch topology. And right now, this switch or bridge is the root, so we'll label that. So all the same rules apply, right? Everything works the way that we've been doing this so far. What I'm going to do is take a look at this port right here, and we're going to send this to gig 01. So we're going to do a couple things here. I'm going to say spanning tree port fast. Okay, now we'll take a look at the warning again, right? Port fast should only be enabled on ports connected to a single host. Okay, so this would be the same as me doing this, right? Right, so this is the instance for port fast. Now, what does port fast do for us? Port fast says, instead of, that was gig 0/1. If I connect this to any other port, right, it's amber. And it's going to do that for listening and then learning. So it'll take 30 seconds. But by going to port fast, it goes forwarding much faster, right? So that's what I just configured on port 01. If I go to another switch, if I just say, I'm going to connect you to another switch, this is what we don't expect, right? Port fast warned us about connecting a port fast port to a switch. So this switch comes in and says, well, I'd like to do spanning tree. Okay, so I'm going to connect this back over here for a sec. And if I go into this port now and say, well, look, not only did I do port fast, but I'm also going to do something called BPDU guard. So I'm going to say spanning tree. And what are my options? Well, there's BPDU guard. We're going to use guard here in a second. So I'm going to say, oops, spanning tree BPDU guard. And I'm just going to enable it. Forgot about that. Okay, so we've enabled BPDU guard. So now what happens when I connect it to another switch that wants to do spanning tree? Well, we can see the messaging that I'm getting right here. Right? BPDU guard error detected on 0/1, putting it in the error disabled port. So what BPDU guard says is, look, I want to do port fast, or even if you're not doing port fast, so this is one of the questions, if you have BPDU guard there, I want you to shut this down if you receive a BPDU. So this prevents misconfiguration, but also is a little bit of a help when bad guys might be around. So let's take a look at our ports now. We can see that I only have one port forwarding, and we can see that this is down. Okay. Well, now what I'm going to do, so that's BPDU guard. So now what I'm going to do is remove BPDU guard. So we just reset the interface and we should be good to go. So now what we're going to do is fool around with root guard. Now we know that this switch is the root. What if this switch came in and said, well, I want to be the root, and it does that because we're going to lower its priority. So we're going to go right back in here to this switch. What I'm going to do is spanning tree guard. Now what are my options? I'm going to say I want to be root guard. I'm going to guard who the root is. So that the root is over here. And we're just going to activate this, right? So we're going to say, okay, root guard. Now what this means is that I want this to be the root. So our switch in the middle is receiving BPDUs from our root, but our switch all the way on the right is also receiving things. Now, if the switch on the right believes that something should be different, then it'll send BPDUs back to the left. So what I'm going to do now is I'm going to drop the priority on VLAN 1. This should make its hello BPDU better than the one that it receives. So I'm going to say config T and spanning tree. Now this is global. Spanning tree VLAN 1 priority 4096. So look what happens here. We get some activity because now our switch on the right believes that it should be root. But what's going on in the middle? Let's take a look at our messaging. So root guard block, port 1 tried to come up and become non-designated, meaning that it wanted to be a root port pointing to a new root, which would be multi-layer switch 0 on the right. But root guard said, oh, no, 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 that's not the way this is supposed to be, because I am protecting this root right here. And so we can see that the port here is in this state of listening. It's not going to switch to the new root. Now in the book, it says this would be broken. This version of the iOS and these devices don't show it that way, but that's what ends up happening with root guard. So that is BPDU guard and root guard. Okay, configuring layer 2 Etherchannel. Now this has come up a couple of times. You've heard it, it's part of the test. You're probably going, what in the world is this all about? Well, here's our example topology that we fooled around with last week. You saw it in Packet Tracer this week. We got a couple of links here. And so what we're going to do with an Ether channel is we're going to bond, at layer 2 anyway, a bunch of links together. Well, what would happen with spanning tree? Well, it's exactly what this diagram shows. It would block one of the ports because it's eliminating this loop here. But in Ether channels, what we're trying to do is maybe increase capacity between the switches or provide some redundancy. And we don't want spanning tree to disable one of them. So what we're going to do is create what's called a port channel and refer to that as one of the Ether channel types that we can have. And we're going to bond these together, and so spanning tree will not disable it. Let's take a look at that in Packet Tracer. So here is our topology in question. We were working with this last week. And so the first thing that I'm going to do is take my ports and I'm going to make them part of a channel group. So I believe these are ports 21 and 22 on this side. Well, we'll be really clear about it. We'll do 1, we'll do 2, we'll do 2 and 3. Okay. So on my root switch, what I'm going to say is I'm going to go to the interface of 0/1, and I'm going to say channel group, right? And I'll show you some of the options here. So we're going to create a channel group. Channel group 1. Now remember that I'm on the interface level. And our initial configuration is going to be manual. So we're going to say mode, and really at this point we're just turning it on. So these are the modes that we have available to us. So we're going to say on. Okay. And then I'm going to do the same thing in port 2. So what I've done is I've put both ports into channel group 1. Now we're still figuring this out. So what I'm going to do at this point is do the other side, and then we'll come back to that. So now I'm going to say on this side of the switch, I'm going to say interface F0/2. Remember, we're using channel 2 or ports 2 and 3 on this side. And I'm going to say channel group. Now, the nice thing is that even though I use channel group 1 on the other side, I don't have to do that on this side. I can say, well, I'm going to pick a different channel group. We'll do channel group 4, mode on. And I'm going to say F0/3, channel group 4 on. Now let's take a look at our running config and we'll see what this looks like. We've got a new interface now. And then we can see that I've added my two interfaces to my channel group. So we can see that there's some activity here, right? There's trying to figure things out. But I can say show port group 4 on this side, or show interface, port channel 4. And we can see a couple of things here. One is that I've got my two ports that I've added to this. But you can also say show Etherchannel. And here is all the Ether channels that I may have configured. Here's group 4. I've got 2 ports in there out of a maximum of 8. Now here's something else that's interesting. Notice that I don't have any blocked ports here. So if I do a show spanning tree, I have a couple things that are going on. One is I know that this is fast Ethernet. So the cost should be 19. But for a port group, the cost is actually less because I have greater capacity between them. So not only are none of the ports blocked, but on a port group, your priority or your cost actually goes down. Now, we're getting very long in this particular video. So if we were going to do dynamic ether channels, what we're doing is we're turning on a protocol to do that. So we would either turn on Cisco Port Aggregation Protocol or IEEE 802.1ax Link Aggregation Protocol. Now there's a little bit different configuration, right? This is the Cisco proprietary. One end has to be set to desirable. You saw that. That's right up here. And if you're going to do LACP, one of the sides must be in active mode. All right. Now we already took a look at what spanning tree does with ether channels. The cost actually goes down and it doesn't block any ports. One other thing that'll screw up your port channels is if the two sides don't agree on things like speed or duplex, or even stuff like how you've configured the two ends of the port channel. Now here's a fun question. If we think about that link, we've got multiple lines between them and you send traffic over them. Well, how does the switch decide which link to use for a particular frame? Well, it turns out that if you set up a port channel, you can decide how that goes. There's a mathematical calculation or a mathematical evaluation of the numbers associated with a particular port channel or ether channel. And the way that you determine that, or the way that you set that up, is with the port channel load balance command. If we take a look at our port channel options, we can see that we've got load balancing. And what are our options? I can load balance based on anything. And so as an example, I might say, well, take a look at the destination MAC address, and depending on what the values are, send some of them that way and send some of them across a different link, send some of them across a different link, or I could load balance based on source MAC or a combination. So the load balancing makes a difference depending on what you're trying to accomplish with your port channel or ether channel. So that is how we decide the link that you're going to use for each frame. Okay, our Chapter 10 look ahead. We are going to move away from Layer 2 and enter into the world of IPv4. So this is the whole Part 4, IPv4. And we are going to start with an introduction to subnetting, at least some of the ideas in subnetting. We'll take a look at some of the subnet math, right? Number of subnets that you need, number of hosts, some design ideas, and then masks. So that'll be a big start for us. All right, so this has been a look into learning rapid spanning tree, or learning a little bit more about spanning tree itself and the various flavors of spanning tree via configuration. So we did a multiple VLAN, multiple tree example. We fooled around a little bit with that and saw how spanning tree resolves itself in the presence of VLANs. And then we also did ether channel stuff. So after our root guard and BPDU guard, remember the BPDU guard protects a port against receiving a BPDU. And the root guard says, I know that that switch over there is supposed to be the root. You're not allowed to be the root, even if you have a better BPDU. So I'm going to protect my root. Our ether channel config is all about configuring multiple lines to go between the switches. And it's not just about increasing capacity, it's also about lowering the spanning tree cost, which is why it's in this chapter, but also being able to load balance across those links. And you can choose how you want to set that up. Well, that's some pretty cool stuff at layer 2. Like and subscribe. All aboard for subnetting and the IPv4 land. And no matter what aggregation protocol you choose or what mechanism you're using to resolve your loops, may those packets or frames always reach their destinations. And remember, this is CCNA certification. You can do this.